Good morning, dear 10th class students. So this is our part 2 for chapter 4, carbon and its compound. Now we are discussing about the one more third allotropes which is found later the diamonds and graphite. Okay, so that is the Buckminster fullerene. Buckminster fullerene. Buckminster fullerene. So this is the carbon 60 structure. It means this is the C60 structure of carbon in which the carbon having the pentagonal and hexagonal shape. Okay, and also you can tell that this is the buckyball structure. It means the football structure is also we have to tell. And this is the allotropes of carbon, which is just different from the diamonds and graphite. Diamond is a too much hardest substance, and graphite is a soapy to touch, but they are having the properties of in between that. So that's why one more allotropes can be found by American architect, that is the Buckminster Fuller. Okay, Buckminster. So American architect Buckminster Fuller. Okay, American invented by Buckminster Fuller, that is the American architect, and they found that one carbon 60 structure. It means the C, it means carbon 60 structure. So Buckminster fullerene is a carbon 60 structure in which that there is a 20 hexagonal shape, 20 hexagonal shape and 12 pentagonal shape. 12 pentagonal shape, like a football structure. Okay, no more question will be asked from this part. Okay, that information is enough to learn about the Buckminster fullerene. Okay, so now we are discussing about the organic compounds. So what is the organic compounds? You already seen that in our things like organic compounds. Organic compounds. So what is the organic compounds? We will see both these things. These things like organic compounds. It means a compound which is made up of carbon atoms. It is made up of carbons, okay? Or made up of carbons. Enough is that. So a compound which is made up of carbon is known as organic compound. Is known as organic compound. And this second name, it is one more name of this organic compound. Okay, I think you already hear the name of this organic compound and inorganic compound. Organic compound, it means the made up of carbon. It means also we have to tell the carbonic compound. And one is that inorganic. It means they are not made up of carbon. It means other than carbon, and they are also known as non-carbonic. Okay, non-carbonic compound. So they are known as carbonic compound. Okay, carbonic compound, also known as carbonic compound. So here, if we are telling about that organic compounds are made up of carbon, then what will be the structure of this carbon in this way? Okay, so one is that if carbon is joined in this way, so that is the linear chain. Okay? that is the linear chain. Okay, and if carbon is joined in this way, like that, this is the branching. This is the branched. This is the branch chain structure. Okay, we have to tell that this is the branch chain structure. And one more is that in which that if carbon is joined, if carbon is joined in this way, that is the closed ring structure. Okay, closed ring structure. Okay, so I hope you are understanding what I am telling here. This is the linear chain carbon arrangement. Okay, it means the carbon arranged in linear chain form. This is the branch chain of carbon atoms. Okay, it means because the you know about that why the organic compounds are most of in the world, because having the two things, that is the two properties, that is the self linking properties, it means self combining properties of carbon, and second is our catenation, it means the tetravalency, because the more number, it means the highest too much high valent carbon is available for the carbon. That's why they are having the more number of compounds and making the complex compounds. So these two properties are responsible for that carbon can make a more number of compounds and large number of compounds. Okay, so closed ring structure. After that, we will discuss about our first functional group, or maybe about the different type of organic compound in which in that first is our hydrocarbons. Okay, hydrocarbon. So what is hydrocarbon? Hydrocarbon compounds. Hydrocarbon compounds. So what is the hydrocarbon compounds? Hydrocarbon compounds. A compounds which can be formed by hydrogen and carbon. Hydrogen and carbon. Okay. So hydrogen and carbon is known as hydro hydrocarbon compounds. There are two types. It is two types. Okay. So it is of two types. What are the types? Look. One is uh, hmm. So, one minute. Hydrocarbon compounds, a compounds which can be formed by hydrogen and carbon. So, you know about like examples. Okay, first is examples like CH4. Because here can it is only hydrogen and carbon combined, okay, and form the compounds like CH4. Okay, like C2H2. Okay, so these are the examples of hydrocarbon compounds. So they are having two types of compounds. Okay, so I can say that is. So there is a two types. I can explain here. That is saturated hydrocarbon. First is saturated hydrocarbon, and second is unsaturated. Unsaturated hydrocarbon. Unsaturated hydrocarbon. So saturated and unsaturated hydrocarbon. So what are the difference in between that saturated and unsaturated hydrocarbon? A hydrocarbon which is which is formed by single bond, single bond, a hydrocarbon which is formed by a single bond in between carbon and hydrogen, in between carbon and hydrogen, like alkane, okay, and a hydrocarbon which is formed by double and double or triple bond, either double or either maybe triple bond between carbon and hydrogen. Example: alkene and alkyne. Okay. So what is alkene and what is alkane? Alkene and alkyne. So these are the important for you. These three structures. Okay. So I hope you are understanding what I am telling here. Okay. What is Buckminster Fullerene? That is the C60 structure. American architect Buckminster Fuller first discovered this type of allotropes of carbon, and this is the carbon 60 structure in which the 20 hexagonal shapes and 12 pentagonal shapes. Next is our important topic is that is the organic compounds. Most all the carbon compounds is known as organic compounds. A compound which is made up of carbon is known as organic compounds. It means carbonic compounds. They can be able to form in these three structures, that is the linear chain structures, branch chain, it may in which the carbon is attached in the form of branch, and maybe sometime in the form of closed ring structure like the benzene structure. Now the first is that is the hydrocarbon compounds, that is the part of one organic compounds and from the functional groups. So a compound which can be formed by hydrogen and carbon is known as hydrocarbon compound, and it is of two types. That is the CH4 or like C2H2. So these are the two examples of this of hydrocarbon compound. But at the broad spectrum, we can divide this hydrocarbon compounds in the two forms, that is the saturated compounds and unsaturated compounds. So first is saturated compounds. Definition is that a hydrocarbon, okay, it means a hydrocarbon which is formed by single bond. It means the saturated hydrocarbon are those hydrocarbon which can be formed by a single bond in between the carbon and hydrogen. But the unsaturated hydrocarbon in which that the formation of bond is by the help of double bond or either triple bond. So it means if single bond is there, that means they are the saturated hydrocarbon, and if the double and triple bond is there, that means they are the unsaturated hydrocarbon. So I hope you are understanding about that. What is the double bond and what is the triple bond for that? So for alkane, we are having a one formula is there, that is the CnH2n plus 2. Okay. CnH2n plus 2. And for alkene and for alkyne, okay, for alkene and for alkyne, okay. So for alkene, CnH2n, and for alkyne CnH2n minus 2. So what is this H and what is this N? So N is number of carbons. Okay, so you have to write down these things. Okay, I hope you are understanding what is this thing. CnH2n is H2n plus 2 is a formula for alkane, and this N is the small n is the number of carbons. It is what the number of carbons in that particular formulas. Alkenes, that is the CnH2n, and alkyne is that CnH2n minus 2. That is the formula. You have to write down. We will come back. Okay. So now, students, before starting the alkane, and alkynes, that is the saturated and unsaturated hydrocarbon compounds, first we have to discuss about some nomenclature. Nomenclature means how can we give the name to the compounds we are seeing in the form of structures. Okay, so for that, the international systems are there, and that name is IUPAC. IUPAC. IUPAC means International International Union of Pure and Applied Chemistry in 1958. Okay, 1958. So this is the full form of this IUPAC name. So this is the union to give the names or to give the nomenclature for any compounds or to make the rules and regulations for that. So some points we have to discuss here for that, like that. If so, I am writing in the short way the points. Okay, you have to make understand of that. It means in the single compounds, if the compound is a bond, single bond compounds, that is alkane. Okay, then double bond compounds, that is the alkene. It means we will put the suffix. For that, we will put the suffix is ane. We will put the suffix is in. Okay, and triple bond compounds is alkyne. That is suffix is ine. Okay, that name is ine. That name is ine. Okay. So this is the thing, Sam. One more things we have to remember here. That is, if one carbon atom is there, then prefix. Okay. Prefix is meth. Okay, meth. If two carbon atom is there, then prefix is eth. Okay, like that. Three meth is prop, but, pant, hats, hapt, opt, non, or this is the DAC. Its pronunciation is DAC. Okay. So this is for 4, for 5, for 6, for 7, 8, for 9, or for 10. It means this one carbon atom is there. Okay, so these are the some rules and conditions for that. determined by the IUPAC. IUPAC means International Union of Pure and Applied Chemistry, which is initiated in 1958. So for that, single bond compounds is that is the alkane. It means the suffix is "ane." Double bond compounds, that is the alkene, that is suffix is "in," and triple bond compounds is that is the alkyne, that is the "ine." So these are the suffix, and what will be the prefix? So for that we have to see these things. So if the one carbon atom in that particular formula, then we will keep prefix is that meth, and if the two carbon atom is that there is a prefix is eth, okay, and then for 3 that is the prop, 4 is for but, 5 for pant, 6 for hex, 7 for hapt, 8 for oct, 9 for non, and 10 for DAC. So DEC, but pronunciation is this one, DAC. Okay. So I hope you can remember that this meth, eth, prop, but, pant, hapt, hex, hapt, oct, non, and DAC. So ane, in, and ine. So these are the suffix. So what will be the things? So now you can understand that with the help of some examples. Okay. With the examples, now we have to realize that what will be the formation of these compounds, like that. So you know about that. I already initiated one formula is for that particular, for alkane, and for alkyne. Okay, and what will be the formula? I already told about that. CnH2n plus 2. Okay, CnH2n or CnH2n minus 2. CnH2n minus 2. So look that. What will be the category of this any compounds that will be determined by afterwards, but first we have to see if there any compound is like that. Example, okay, for that example we are having C8H12 is the compound. What will be the name of this compound? So how can we determine like that? If carbon is 8 and hydrogen is 12, then it is your choice how can you determine that, but you can think that first is making the structures. So like that we have to make first that 8 carbon we will write 8 carbon, 1 2 3 4 5 6 7 and 8. 1 2 3 4 5 6 7 8, and now we have to join the total number of hydrogen is 12. So look, 1 2 3 4 5 6 7 8 9 10 11 and 12. I think this is 5, this is 6, and this is okay. So this is already 12, but now our carbon is left. It means maybe the chances of there is a no single bond. Okay, it means there is a chances for there is a no single bond, and if we are keeping here that is the double bond, then we will erase one carbon. Okay, that means if we are using the double bond here, then we are just making it means erase one hydrogen, because now the carbon valency are already fulfilled, because now carbon is joined with this 4 different ways. It means by 1 from hydrogen and 3 from carbon. Okay, so now also if we are counting the hydrogens, then they are not fulfilling the categories, because now also we need some. So what will be right total if number is 8? Okay, then other is one more chance is there, then we have to clarify that to putting in the formulas, so like C and H2n, it means if carbon is 8 and hydrogen is 2 into 8, then 8 and 8 into 2, it means that is the 16, and second one is if we are keeping here then 8, then 8 into 2, okay, 8 into 2 plus 2, it means if C8 then 8 into 2 16 or 18, then this is the C8H 18, C8H18, and this is the C8H16, and this is the C8H2 into 8 minus 2. It means C8H8 into 16 minus 2, it means 14. So when you will see that, see this is if with the carbon 8 there is the formation of with if alkane compound, then the carbon is 8, then the H will be the 18. If the alkene is, then C will be the 8, then the H will be the 16, and alkyne then C8, then H will be the 14. It means this C8 and H12 cannot be exist. So one is the way through which you can determine, but now you know about that. I already keep here two bonds, and if I am keeping here 3, then also look, okay, maximum I can wrote 3. Then also if I am now I am keeping this 12 hydrogen, then 1 2 3 4 5 6 7 8 9, and one more hydrogen I have to remove from here, okay, and one more hydrogen I have to remove from here, okay, because if already carbon is joined here 3 and here 3, okay. So look, 1 2 3 4 5 6 7 8, this is 9, this is 10, this is 11, and this is 12, okay. So 1 minute, 1 2 3 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4 3 4, and okay. So you can see here it is the position of this H, and here is the position of this H is remaining. If I am keeping here, it is 3 bond. So I hope you can understand C8 and H12 structure is not possible, because with the C8, if H18, then alkane structure is possible. With the C8 H16, then the alkene structure is possible, and with the C8 H14, then the alkyne structure is possible. So you know about that. This structure is not possible for us. Okay, cannot be exist this structure. Okay. Now, if you are thinking about the one more topic example for that, then you can look that like C7 and H16. C7 and H16. So what will be the structure? Look for that. Look, C7 and H16 means 7 into 2 plus 2 means C7H16. So this will be the alkane structure. This will be the alkane structure. It means I can write here the alkane structure. Then I will use only the single bonds for that. Okay, 1, 2, 3, 4, 5, 6, and 7. And now I can join the 16 hydrogen to that with the single bond only. Okay, this is the single bond. This is the single. Okay, because 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, and 1, 2, 3, 4, 5, 6, 7, 18, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay, so this is the C7 and 16 structure. So with the help of this, we have to write. But now it is a time to give the naming. So this way you can find that how to make the structure. Now we have to write the names. So you know about that. With the when the carbon is 7, it means the carbon is 7. Then we have to write the name of Hapt. We have to choose the name Hapt as a prefix. And if the bond is single in between that, then look, if single bond is there, then alkane, it means the suffix is "ane", that is the ane. Okay, so on the number of that carbon, we have to introduce the name of like that. Okay, look, like octane, and octane. This is the only examples. Okay, for 4 carbon, that is the but plus ane, yani butane, because single bond. But, it means 4 carbon is there, then and double bond is there, then butene. It means in the form first prefix it shows the number of carbons, and last one in and ine is just shows the double, single and triple bond. It means single, double and triple bond. So this is the butane. This is the butane. So you can easily see what will be the structure of for that, like that. Octane, there will be the structure of C8H18. Okay, for octane, that structure will be the C8H16, and for the structure that C8H40. Like pentane because carbon is 5. Okay, then just double it and make 2 plus. Like just double is 10 and make 2 plus, that is the 12. C5 and H10 just double only, because the number of carbon and number of hydrogen is just difference is only of double the carbons. Okay, that means C5H16, and this is the C5 and H14. Sorry, C5H8, C5H8, like C8H18, C8H16, okay, and C8H14. C5H12, C5H10, C5H8. So these are the structure for that. More structure you can able to make. It means for any that you have to write. Like if you have to write the structure of hexane. Okay. If anyone is tell that how to make the structure of hexane. So first you know about that. Ine means carbon having the triple bonds. Carbon having the triple bond, and hex means total number of carbon is 6. Total number of carbon is 6. So look, 6, 1, 1, 2, 3, 4, 5 and 6. Okay. Now you have to join only the number of hydrogen. So look, and you also knows about that. In hexane there is C6H10. Okay, C6H10 only. Okay. Because just double is in the alkene, and from the double and -2, that is the alkyne. So C6H10. So 1, 2, 3, 4, 5, 6. Okay. So now the hydrogen I have to join. Okay. Already now 4. 1, 2, 3, 4 carbon already joined or linked with the one with 4. Now here it is. Now here it is, one carbon is already joined with the 4th, and here it is. Look, one H, and this H, this H, and this one more H. So how many hydrogen can be joined with that? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this is the C6H10. Okay. So more doubts will be clear with only with the practice. So this is our hydrocarbon, different types of saturated and unsaturated hydrocarbons. In that alkane, alkene and alkyne is that. Alkane is with single bond, alkene is with double bond, alkyne is with triple bond. And what will be the structure, will be the form. It is depend on the prefix and suffix. Prefix is with the one carbon atom, that is the meth, eth, prop, but. Okay, with the 2 and like that. Okay, order. And for the single, A, double, in and triple, ine. So from that we have to able to make the structures. Okay, and we also have to able to give the names of these structures. Okay, so thank you, and in next video we will discuss some more topics. Okay, thank you.